Hello friends, welcome in the lecture series on basics of statistics. In the last video, we learned about partition values. So in this video, we learn about the range and quartile deviation. So let's see. So what is the range? If capital S is the largest observation and capital S is the smallest observation, then range is the difference between largest observation and smallest observation. So therefore the formula of the range is largest observation minus smallest observation. Very simple. Let's see some applications of range. So range is the suitable measure of dispersion in case of small group with less variation. If we have a small group of data and less variation, then we can use the range. So first application of range is it is widely used in the branch of statistics known as statistical quality control. If you are from the statistical background, then you know that statistical quality control. So in that statistical quality control, we shortly name as SQC. There we can use the range. Next application is temperature at certain place is recorded using maximum and minimum value. Third application is range is used in the medical science to check whether blood pressure, HB, hemoglobin count, etc. is normal. Here these are the applications of range. Let's see about quartile deviation, or we also call it as semi-interquartile range. The range use only two extreme atoms. Hence, any change in between observations is not going to affect the range. This is the main drawback of the range. Moreover, in many situations, extreme atoms are widely separated atoms. That means when we find the range, we use only smallest observation, largest observation. We not consider in between observations. In order to overcome this drawback, range of middle 15% of atoms is computed. So clearly the middle 50% atoms lie in between two quartiles, first quartile and third quartile, Q1 and Q3. About the quartiles we learned in the last lecture, so you can watch that lecture. I will put link in the description box. The measure of dispersion based on these quartiles. So how to find quartile deviation or semi-interquartile range? The formula is Q3 minus Q1 divided by 2. Very simple, just difference between these two quartiles, Q3 minus Q1 upon 2. Let's see one example, very simple example, so you can easily understand. Compute range and quartile deviation for the following data. We have given some observations 100, 24, 14, 105, 21, 35 like this. Let's see the solution of this question. First is range. So we learned that formula earlier. Smallest observation is 14 in our data. Largest observation is 106. So range is largest observation minus smallest observation. Just substitute the values. 106 minus 14 is 92. This is our range. Second is quartile deviation. So when we want to find the quartile deviation, that's why we arrange the observation in ascending order. Why we arrange the observation in ascending order? Because we want to find Q1 and Q3 quartile deviations. That's why we arrange our observation in ascending order, or you call it as increasing order. Okay. So Q1 we learn about quartile deviation. So Q1 formula is the value of n plus 1 by fourth observation. That means our n is number of observations. So 15 plus 1 divided by fourth observation. So our first quartile is 21 because fourth observation is 21. Third quartile Q3 is value of 3 into n plus 1 divided by fourth observation. Means n is 15 number of observation. So 3 into 15 plus 1 divided by 4 is our 12th observation. So 12th observation is our third quartile. So third quartile is 100. Okay. Thank you for watching this video. Very simple. You watch whole video. You can solve your own this problem and then match the answer. Thank you. Then quartile deviation is Q3 minus Q1 upon 2 is equals to 100 minus 21 upon 2 is equals to 39.5 is our quartile deviation.